This is homework 15-14, so I'm going back a little bit, but sometimes when they ask, what is the impulse required, it's kind of overlooked that the fact that we can just say the impulse is the change in linear momentum. And so, even though we don't know the force that's getting integrated, it's still equal to the change in linear momentum. So, that being said, what we have is a train car moving at 0.75 meters per second, and it weighs 20 times 10 to the third kilograms. That's its mass. So they want to know the impulse needed to stop the train car. So we only have enough information to work with momentum as it is, really. Impulse means change in momentum. Let's go ahead and use impulse momentum theory. So you could either say m1 v1 plus the impulse is equal to m2 v2, its final momentum. I'm sorry, m1 v2. Or we could just use this definition that the impulse is the change in linear momentum and say the impulse is equal to m1 v2 minus m1 v1, or L2 minus L1. And its final velocity is 0. So the impulse is going to be a negative m1 v1. It's going to be applied in the opposite direction of its initial momentum. It was initially moving to the right, so an impulse is going to have to be applied to the left of equal length to stop it. And I get an impulse equal to 15 times 10 to the third Newton seconds. We could have taken this and solved for it also and gotten that the summation of all the impulses, T1 to T2, even though we don't know any of this information, we can still say that all of that equals 15 times 10 to the third. Either solution works. Basically the same thing, right? We just took this and threw it on the other side, and that's how we got our definitions. Thank you.